Thank you. Well, first of all, I've been, presenting at a couple of different jugs over the past couple of months, and this has to be the best organized jug of all of them so far. I was at the London jug last week, and I was telling them there's only 30 or 40 people that showed up, and they were not Java enthusiasts. So it's actually kind of a good idea to have Java enthusiasts at a jug. So I'm glad to be here. I'm from San Francisco. I'm the founder, CEO of Codenvy. The company itself is about a year and a half old, but what we started working on, we started on in 2009. A little bit about myself and my background, why I'm here. I started working with Java in '97, approaching almost 20 years with it. I started off as an instructor right out of university. I did a introduction to Java, object-oriented programming, Java EE when it first got going. That company was acquired by BEA. I spent 7 years at BEA. Some of that in developer evangelism, some of it in product management. And then after that, I ran the middleware company, which they had a property called theserverside.com, which eventually got bought by TechTarget. And then I spent 7 years at a company called Quest, and they got bought by Dell. Now I'm a venture capitalist. I've invested in Zero Turnaround, the JRebel guys, WSO2, they make an enterprise service bus and a middleware platform stack. I'm an advisor to Tommy E, an investor in Cloud, a database as a service, and I'm also a founder of Codenvy. And we got started with Codenvy a long time ago, and we got started with it out of a lot of frustration. So I had risen in various management ranks, and I got fairly unskilled with Java. And there was a point in time where I was tired of product management, tired of rising ranks, and I sat down and I said, I'd really like to get my Java EE skills back. I had written a book on Java EE at one point in time, and I'm like, okay, I'd like to refresh those skills, get current with the latest specifications. And it was an incredibly frustrating experience for me. It took me well over a week to get Eclipse installed the right way. Then I switched over to IntelliJ. I was dealing with all the different application servers that was there. The frameworks had moved on. Maven wasn't around when I was still doing Java programming, so you had to relearn Maven, and then there was Gradle. And so just, getting everything configured, getting to the point where I could do a hello world was this, this obnoxious amount of time. And it was very frustrating. We said, there could be a better way of doing this. At the same time, I was an advisor to this French company called Exo Platform. They make content management software that competes with Jive and Yammer. And they had started kicking the tires a little bit with a social gadget IDE in the browser. And this was in 2009. And they had published that as a way to test some multi-tenancy IP that they had built in the JVM. They were just hoping to get about 100 people to hit the system all at once. And it turns out that little social widget factor they built was actually more popular than their enterprise content management platform. There was a lot of users who started kicking in and saying, hey, it's in the browser, what is this? This is great. And they asked them, hey, would you add some Java support? They added Java support. And then they said, hey, this is awesome, could you add a compiler? So they added Maven. And hey, this is awesome, could you add deployment to Google App Engine? And they did that. And sure enough, they got to the point where they had about 10,000 users who were using this system over the evolution. So between my frustration of getting things going and their kind of kicking the tires with browser-based IDEs, we started really seriously looking at what was going on in 2011, and we saw a pretty big opportunity. And the opportunity wasn't to compete with Eclipse. The opportunity wasn't to compete with IntelliJ. The opportunity was to solve some pretty fundamental problems in development that had not been solved before. And so at that time, at the beginning of 2012, we said, we need to take this IP, put this vision together, and take it a crack at it. And we knew that and we're going to talk about what our kind of vision is here and kind of try to recruit you guys to start working on some IP and collaborating with us on this. But what we realized is that the vision we had and the problem we wanted to solve couldn't be solved by four guys working out of an office together, and it couldn't even be solved itself by 10 guys. It was going to require a team of maybe 30, potentially 50 people. So we went out and raised $9 million. We grew the team. We're now 50 employees, most of them in R&D. And for the past 2 years, starting at the beginning of 2012, we had thrown away everything that we had published online, and we started rewriting everything from scratch. And we were going to take a much bigger, different take on the market. We left the legacy generation stuff online, and that's if you've logged in and you've used this system, that's what's out there. It's been out there for a number of years. We've got 125,000 users of that, which is really kind of stunning to us because we really don't market ourselves. We've done some, webcasts, we do some webinars, we send out emails, we try to participate in the community events that are there. But yet, every week we get, every month we get 3, 4, 5,000, new subscribers on this. And even with that, that was kind of signaling to us, there's a lot of interest in this, something very interesting going on here. We've gotten some customers lined up as well, and they're pretty fascinating. But this is the problem. And I expect all of you in the back to be able to read that. But this is the quick start guide to installing Tomcat 7 with Eclipse. We all do development here. How many of you have a wiki page on your website that tells you or some other team member how to set up their developer environment? Everyone in the room raised their hand, right? Is that wiki page a half a page long, or is it, well, I guess it's one wiki page long, but the question is how many lines of a wiki page long is it, right? These things are sometimes as short as 10. If you're lucky enough to use, how many people are using Vagrant? Anybody using Vagrant to set up their developer environment? Nobody, okay? If you're lucky enough to be using Vagrant, you might be able to cut it down to like 10 or 15 lines. But for the most part, a lot of these systems take 40, 50 steps, right? And why is that? There was this fascinating study done. I don't know, whether we can believe it or not, but Electric Cloud, LinkedIn, they interviewed 1,200 engineers like us, and they basically said, how do you spend your time during the week? And these people reported back that they spend 13 hours each week dealing with environmental configuration issues. That sounds blasphemous, right? Because we're all power developers. We grab our laptop, we install everything, we're in control of that environment, and we have it just right. And once it's set up, our time is 0. So the idea that you're spending a third of your week on configuring stuff is kind of ludicrous. It's actually not so ludicrous, because if you start looking into really where we spend our time as individuals or on the team level, and you start adding it up, there's a lot of things that we do repetitively that we take for granted as just the way it is that add a lot of tax to how we spend our time. We've listed these things here. We think most commonly, okay, if I'm going to set up a new environment, that's a time associated with that, and that's a very manual task. But there's a lot of other things, right? When you change branches or change projects, it's usually not as simple as just push a button and you're ready to edit some code and compile again. There's usually a series of environmental configuration things that you have to do. How many times have you added or updated a plugin on Eclipse and you have to restart your computer, or it crashes, or you just have to completely uninstall Eclipse and start over again, right? It's a non-zero time. How many of you guys get compilation lag because your company won't buy you enough RAM on your desktop, right? That happened to me once when I was really young. I only had like 2 gigs of RAM, and I'm taxing the heck out of that machine. I've got, all my productivity apps open, and I'm running a compilation, and I'm trying to edit. Suddenly the thrashing time, the compilation lag, this is an impact on your productivity. This is taking away from your use of the system. If you go into Jenkins and you've got a failed job, right? Someone broke the build and you're responsible for investigating that. Now you've got to take the time to go back and say, okay, well, which code branch did this build come from? How do I reconstitute an environment so that I can try to reproduce the same circumstances to figure out the root cause of this issue? That time you have to put into that is effort into configuring this environment. If you're using Vagrant, you're downloading a VM. You have a VM image that you use. Well, that image updates itself, and now you've got to resynchronize. You've got to download this. If you're on different hardware, most of us run 2, 3, or 4 machines. Now you've got to repeat that exercise for every machine. When you start getting into the team level, you've got tribal knowledge. So the tribal knowledge is, a team member of 10. There's usually, 2 people on that team who know the environment inside and out, and they start having to help other people get their environment set up, because even though you follow the wiki page, something always breaks. There's some tool you're not familiar with, and the tribal knowledge guy has to come in and save the day. Environmental technical debt. As projects age, and then a bug shows up, and you need to go and reconstitute an environment that's older, you might have lost the talent, that the hardware may have aged out. There can be any number of things, not to mention just, it's gone into a back portion of your brain. And so it takes a lot longer to get one of those systems set up again. So lots of issues. On the IT security front, every financial institution I talk to, they get freaked out. They have some sort of offshore or nearshore development team. They want that team to be engaged, but yet they're terrified that their code's going to be stolen. I actually talked to Fidelity. They said they've got 1,000 Android developers in China. They are employees of the company, but they'd like to create a development environment where the engineers can edit the code, but they can't download it. Right? And they're like, the desktop development model kind of presents challenges for them in that system. So, interesting things that add up. We make not an IDE, but the problem is in this configuration. Configuration is the problem. It's not about doing a cloud IDE. And the configuration problem is massive. And so we make clouds. And we make clouds of developer environments. And so it really, when you say IDE, our brains wrap themselves around that it must be the editor and the plugins and the thing that connects it all together. But the actual developer environment is much more substantial than that. It is obviously the IDE and the editor, right? But you need your SDM client, whether it's Git, Subversion, Perforce, whatever it's going to be. It needs to be connected to the right code repository. You've got to have the project space with the code properly structured inside of that. You're going to have some series of code assistants, whether it's something as simple as syntax color highlighting or autocomplete, right? Maybe it's refactoring capabilities, but there's layers of code assistance that you need to make yourself more productive. But then you need a builder, which includes a compiler, a packager, and a unit tester, and we all have our unique processes for that. And then you also have to run your own runner, your own mini production system. So you've got to have the app server, right? You've got to have the databases, you've got to have the frameworks. And then you've got to have a mechanism to push these changes out, whether it's deployment, connect it to your issue management, if that's what you need to do, and then any other proprietary plugins. And unless you can put all of those things together into a unified environment, your environment is incomplete. So we make developer environment clouds, and we're focused on making these environments fast, secure, extensible, and instantly provisioned. And we're going to offer them as a public cloud and an on-premise cloud. And what we're going to show you here is stuff that we started working on beginning of 2012. We've got 100 man-years of engineering effort. Just starting last week is the first time we've done any public displays of this. We're hoping to go GA with a lot of this stuff in Q3. This is looking at our burn down charts. We're on track for that. Also, everything that we're going to show you is going to become an Eclipse project as well. We just took a board seat. We become a board member of the Eclipse Foundation, and this is going to become a top-level project dedicated to cloud development for Eclipse. And it'll be up here at the Eclipse IDE. But when you look at the developer environment, the interesting model here is very different. It's not about how many interesting features I can pack into the IDE itself, but how much of configuration can I eliminate? And then what security controls can I put into it as a result? So the first thing is, you got to be able to provision instantly. And when I mean instantly, the environment needs to load in seconds. Nothing to install, nothing to maintain. It needs to be complete and comprehensive. And then when you can do that, if you can provision through an API or a CLI, right, in an automated way, then instead of having an environment per developer, now you can have an environment for every individual task. Every issue, every project, every developer, right, every code review could have its own proprietary environment. It needs to work with any IDE. I'm an IntelliJ guy. I like it. Love the product. Our engineers use it, right? And you can use any IDE, and that the IDE can interact with the system, and the IDE can provide offline benefits if necessary, right? But once you have that, once you start treating the environments as objects, as blocks, it becomes deadly simple to clone them, share them, set privacy controls on them, and then embed them inside of other products, making that single-click access to that. And then you can scale it. You need 24 gigabytes of RAM because you're doing some intensive work. You should be able to click, add the RAM, add the CPU to that environment, go, and when you're done, deallocate the hardware. And if you're going to do this on-premise and manage it for a large group of people, you should have an infrastructure that will allow you to have a maximum density of concurrent development on the least amount of hardware. If you think about development, when we're using our machines, it's the most inefficient use of our hardware that you could imagine. When you're doing editing, what is that? That's I/O intensive, right? Refactoring, editing, you're doing file manipulation, heavily I/O intensive. When you're doing building, CPU intensive, right? And when you're running, generally running is memory intensive, and you're rarely doing all three of those things concurrently. So in that situation, if you're just spending $4,000 per developer desktop each time, you're actually paying for a lot of hardware that's going unutilized most of the time. And when you go home at night, right, that hardware is just sitting there. You might be searching, you might be using SETI, right? You might be helping the world look for extraterrestrial life form, but it's mostly just sitting there. And if you're doing around-the-world development like most of us are, you could have a single computer and service the needs of multiple audiences. So the way we've approached this is that we've taken what was that long wiki page and we have put it into a configuration format, and that configuration format can be embedded in a URL. So a single URL can have the entire configuration of a complete and comprehensive developer environment. And when you click on that URL, you get exactly what you asked for. So, enough of me babbling. We are on staging servers. This is pre-release technology, so if you see any things like 408 errors or pixels that are missing, not my fault. In fact, there are a couple of known bugs, so if you see anything that you don't like, let's just assume that it's a bug. Alright? Okay, so to show that it's really not, let's do this. Paste. So, that's a JSON file, and I just ran our command line, and it spits out, that JSON file is a configuration format, and it goes and it converts it into a URL with a bunch of parameters on it. And if I want to, I could just hit launch. And now it's taking that URL, and it is creating an environment off that. I can run it again, and I can run it again, and I can run it again, and every time you run it, you get a completely different environment. Now that 408 is a Chrome bug, that's not us. That's a bug in Chrome. It'll be fixed in the next version of Chrome. Just want to confirm that if you see that. But here you go, 3 completely different environments booted up in about 20 seconds there, right? So the power, and this is running on our legacy system, but the first thing is that you can create a template with a URL. You can pass the URL around IM, email. You click it, and you get a completely different environment. The environment itself is temporary. You can see that this URL format is very different than the one in here. This one, this factory, is a template, and every time you click on the template, you get an instance of that environment. And you can see that these are each different numbers. This is ending in 9, this one's ending in B. And these are completely functional environments. You know, I can click here and click run, and it's got the runner in there, and it's off building that project and running it there. What makes it temporary is that it's not persistent. If I were to close this tab, my work is lost. If I close this one, my work is lost. You can make it persistent. Copy it to a workspace. At any point in time, you can persist it, and then it's there forever. But the purpose of a temporary workspace is a hack space. You know, I need to investigate something, play with it, run it, compile it, and when I'm done with it, I'm done with it. Notice that I'm not logged in. I didn't need to go through some crazy cloud to authenticate myself. I just clicked it and ran it, and it's good to go on that. The configuration of these environments is in JSON format, right? The environments represent the box that I showed before. There is a designation for an SCM client, the source code that it's coming from, all the plugins that you need to have. It specifies the project type, the builder type, the runner configuration. It's all in there. You can even go so far as to take these configurations and do interesting things like set policies on it. So you can create one of these templates and then invoke a policy that says, this environment can run 5 times and then disable itself. Or this environment is valid as long as the user has a password. So every time the user clicks on it, they have to enter a special password, and then they can go and create this environment. So very simple things. Let's go into some more interesting examples, shall we? So this one. So this is our legacy system. This is the next gen stuff. One of the powerful things of being in a cloud developer environment. Let's see if is it big? Is that readable, by the way? Is that readable, or you want it bigger? It's good. Okay, great. Is that the system can get incredibly smart. So we launched this factory. But then after the environment launched itself, it started running some jobs behind the scenes. And so in this case, it's a AngularJS project, and it's got a Bower JSON. And Bower JSON designates a series of dependencies there. And so it installed an NPM plugin, and it recognized those dependencies, and without me having to click anything, it's off and running and downloading the internet as we speak. I don't think it's done yet. It's going. You can see it's going kind of crazy there. And so it's downloading the internet, and you can automate that. Right? In fact, you can automate a bunch of jobs. The system can get pretty smart about detecting the various jobs that are there, and can kick off various threads on that. You can run the apps, and when the app is running, now what it's doing is it's actually creating a completely separate image. And so this is actually running on a separate VM, and you've got the runner there. And in this case, this example is MuleSoft. MuleSoft has an API editor there. And so we opened that project, we cloned it from GitHub, we downloaded all the dependencies that were there, and then when we ran it, it ran and it gave us this URL that you can't read, but that says runner.codenvymarket.com, and some crazy port number there as well. So that ran. Right? It's pretty useful. Let's take a look at what's going on here. First is that we as our designers are heavily inspired by Sublime and IntelliJ from user interfaces. Let's see, we've got to actually shrink this so I can make use of this. Let's go and take a look at the Spring app. finish this. And so we've got a pom.xml here, right? And first thing you can do is come here and start building. And when it's building, what it does is it's smart enough to analyze the dependencies. If you go and add a dependency to the Maven, it'll go and download that from the internet. And so when you're in a cloud developer environment, though, we can get smart and start doing caching. So we'll operate a nexus at the cloud level, and then we'll host all those dependencies, but then we also place a secondary nexus into each developer environment as well. So if you have a named account, you can get a secondary nexus and it's double cache in that sense, right? So that it's immediately available there. You can see that it did built and it's got the war there. But let's go and take a look at some of the code. Even though it's a browser environment, let's get rid of this. It's a very responsive environment. It's incredibly fast. The editor is near desktop speeds. You can do things like autocomplete. And you notice that it said processing there, but I've got the methods that I need here. And if I escape that, you notice there was like about the second and a half that first time, but it was instant the second time. So the system can get really smart in helping you out in that it can take all the Java code, and the first time you need to process the abstract syntax tree, it can do that on the server side. Then it can keep a binary representation of that, sends back all the code assistant capabilities that you need, and then it keeps those cached in the browser, and you can use web workers to hold on to that and manage that for you. The autocomplete can be smart, right? Here, you get help on the edges. If you saw here, I think up somewhere up here we had some warning signs on the imports. You can click on that. No proposals for this. There's a proposal for this, so I can remove that, and I'm all good on that. So there. So let's go ahead and run this. It's a Spring app. So it's running. And we'll let that get going. Got to run here. And we run it, and we've got this typical Hello World Spring. We hit OK, and we're good to go. All right, so this is Java. We're Java developers. Let's go ahead and stop this. And let me open up this window and explain to you how did that run or work. Now, as Java developers, we absolutely require configurability. We require power. And so if you notice, we had down here the standard Spring output. This looks like, I think this is Tomcat down here. But up here is step 0, step 1. Does anybody know what this stuff is? Has anybody seen this sort of output before? No one? Anybody here played with Docker much? No. Are you kidding? Okay. All right. Docker is a container technology. It was invented by Solomon Sykes. It came out of .cloud, which was kind of a PaaS provider. And it was an open source technology that they developed. And this open source technology, they launched it about 15, 16 months ago now. And it was the underlying engine of what their PaaS had been. And it's so popular, it has taken off. I mean, we're talking one of the most popular open source projects on the planet right now. And they renamed the company, they shut down the PaaS, and went all in on this underlying technology. What Docker does is it does a couple of things. One, it uses LXCs, Linux containers, as opposed to full VMs to create a container space. And when you use Linux containers, you can create basically a very thread-based virtual machine, and it launches in about 200 milliseconds, right, inside of a single process. So we're incredibly fast boot time. The second thing that you do is that the configuration of the container is recipe-based. And so you can actually set up step 1, step 2, step 3, and so not only does it launch launch a container in about 200 milliseconds, but then it also configures the insides of it just as fast. So these step 0 and step 1 commands are actually Docker recipes, and you can create an infinite number of configurations. So you can put different JVMs, different JVM versions, different app servers, all those different things into a running container, and then execute commands inside of that. So what we're doing with these runners here is we actually have a big farm, a massive farm of Docker containers that are running. And when a developer says run, we actually take one of those images, take the recipe that's appropriate, and actually on demand create an image that is exactly what the project needs in order to run the code. And then after the image is created, we shove all the artifacts from into it in a post binding scenario there. So you can see here that it grabbed from Codenvy JDK7 Tomcat 7, which is the image. It was a prepackaged image that we have. But if we wanted to, I could come here, click Custom Run, and we've got these other app servers here, and I can just say Codenvy, and when I run that, it's booting up a new runner, and so now you see step 0, and it's from it's a different base image. So it's using Docker again, but now we've created a completely different image. We booted it up, and we've run it, we insert the assets into that, and now you have the same Spring application running on Tommy E. What's one of the powerful things about cloud developer environments is you can have a sysadmin, your sysadmin, install every JDK version, every JVM, every app server version, every framework version on the planet, and at a click of a finger you can have it available to you because it's cached, it's part of the centralized cloud, and it's made available on that. So the configuration time goes down to 0. I'm going to stop this again. This time I'm going to do let's do a debug session. So even though it's running in a completely distributed fashion, it doesn't prevent you from debugging, right? You can still open up the debugger port. You can still set breakpoints. Let's make sure we got this thing booted up here. And you can still have a distributed system interaction. So you can have a debugger. And by the way, I want to emphasize, even though we're showing a browser-based IDE here, all of these interactions come across these API set that we've been building and that we're standardizing. We're going to work with the Eclipse Foundation to standardize these. But these APIs represent all the atomic functions of developers. Build, compile, analyze dependencies, create project, delete project. I think there's 75 in this list here. So all our browser IDE is doing is it's just a dumb, thin JavaScript client that's interacting over these APIs the same way our Eclipse plugin does. And I'll show you what that looks like as well. You're in here, we're up and running. Let me just set a, there we go, got a breakpoint here. We can go to the runner. Sorry, my mouse, this is a better mouse. Stop using that. All right, we can type UJOG, we hit OK, and if you notice, it paused. Not finishing, I come back in here, get to the debug tab, and there it is. Right? You've got a debugger in here. We've got this is a legitimate bug, this drawing issue that you see down here. Somewhere in here is the value of that. There we go. Go there and change, play, come back in there. Oh, it didn't stay. All right. Well, that may be a legitimate bug. Anyways, real debugger. That's right. Back into the runner. Stop that. So far, everything we've shown you is web apps, right? But doesn't need to be. Just because we're operating in a browser, just because it's a cloud scenario, doesn't mean the output needs to be a web app. I love doing this. This is a Swing app here. there, and here's a runner, and now you've got a hello world with that up in the swing app as well. We slap on a VNC client and go to town. It can be console apps. Stop that. So we got one here. We got an app, static void main, hello world, run it. Great. Building through an image. And then hello world. Now that took a little bit longer than what you would normally do, right, on your normal computer, but that's because it had to constitute the image the first time, run it the second time, and it was nearly instant. It's got the image, it's cached the image, it's available in your workspace, and it runs it there. Okay. We'll do 5 more minutes of talking here. We believe that given another 5 to 10 years, we can make all scenarios of development using a cloud provisioning system faster than anything you can do on the desktop. I know that most of you are going to be like, this guy is smoking something, he's from San Francisco, I need to get me some of that. Right? Here's why we believe it. Right? First of all, you can cache, tremendous caching in the browser. A lot of memory optimization there. Most of those environments that I have running were about 80 megabytes of RAM. You can profile them, you can watch them. You can do incredible things with JavaScript on the browser side, whereas you can only load it on demand. So we haven't even structured our system this way, but we can load only the JavaScript that's needed for the screen that you're looking at. And so if a full, say, browser client was 5 megabytes, you could load it in 100 kilobyte segments and actually do development along the way and get better and better until you've touched every component that you need. The multi-user processing is huge. We didn't talk about it, but behind the scenes, when we run this cloud at full strength, there were 11 nodes there. And so a single developer could at any point in time be touching 11 different computers. The way we do that is we are separating code assistants, editors, builders, runners, API calls, data source management, all onto completely different clusters. And then there are queuing systems that sit in between that. And so when you're using the system and you send off compilation, it is a non-blocking event to your editor. Right? The compilation is off on another system. The editor has received the updates and it's getting that stream in real time. And so we can continue to break these apart, and you can do really interesting things with the queue management. So you can actually send off 2, 3, or 4 different builds all at once, and they go onto separate slaves. Right? And so this can become a configurability for the sysadmin who's controlling the cloud. For you as the individual, how much parallelism do you get? Do I give you one slave and then I can strain the resources? Or do I give you a bunch of slaves and give you a lot of resources on each one of those? This concept of separation processing is very powerful. We haven't even taken it to its full extent. We have a relationship with the company Epic Games. They make a 3D engine, and they just open sourced it, Unreal 3D. It takes 45 minutes to compile on a desktop with 24 gigabytes of RAM on it. And it takes about 6 hours to set it up in order to download all the C libraries, C and C+ libraries, and get the compiler. Because you can have pre-formatted images and you can do incremental linking, we can actually, in about 30 seconds, launch an environment and make a modification to C and actually recompile and relink that in 30 seconds, down for 45 minutes. So we're going to do a special thing thing, they're going to want to try to bring 3D gaming to high school students. So we're going to try to make it as accessible as possible. Click and go with that. We have barely scratched the surface of what we can do with these recipes. There can be layers of caches of images. So you can have images at the central system, you can have images down at the environment, and eventually we can allow you to sync these images offline. So you can, and in this system, you could conceivably say, I have a perfect developer environment, let's snapshot the development environment, sync it offline, and if your offline system supports Docker and the appropriate technologies, you can run it offline, and when you connect again, it'll sync back up and completely run. It'll be identical to that. It's probably a couple of years of work for that, but this is possible with this sort of technology. On the security stuff, we didn't get into that, but there's total privacy controls. You can restrict behaviors. You can track activities. You can do interesting things like have an analytics system behind the scenes. And so if I come here and I were to take a look at session reports, this is actually Codenvy data. We collect 550 events from what developers are doing, so we can automatically track the time of every developer. I wanted to show it to you. It's like Google Analytics for your developer team. We can actually, I can trace everything that every developer does. If I go down to the session, and I can see everything that you did in the IDE. I was with the CEO of AXA Technology, and they run about 2,000 developers, and this was, I didn't know how to respond to this question other than say, yeah. But he's like, he was getting excited by this, they're going to do a deal. And he goes, so I'm really getting excited about using Odesk as a way to compete with my employee staff. And so can I take the job and give it to like 4 people in Odesk in Asia, and then the next day take a look to see who was the most effective with the same job? And I was like, well, yeah, you could. I don't think that's going to really make your employees feel very good. He was like, this is great, right? So I can really see, these guys, they're charging me 8 hours for this job. How many hours do they actually spend in the IDE? You can see that here. It's the same sort of thing. Where did my engagement come? Where was my abandonment? It's all in this system here. We collect right now, with the engagement that we've got, we're collecting about 10 megabytes of data. But we can start to analyze this to see what are the most common dependencies. Right? What are the most commonly used IDE features? What are the most common workflows that are breaking and taking the most time? A lot of capabilities like that. The reason we came here, and I'm going to open up for questions pretty soon, is we've got an SDK, and so it's just like the Eclipse RCP. It's you build plugins, and at the lowest layer we have just a servlet container. And so if you run the servlet container, it'll generate an empty web app. And it's empty. And so the entire web app, both the server side and the client side, is a basket of plugins there. And when you write a plugin, it's a Java class. It's written with injection, gin and juice, here with GWT. And when you compile that Java class, we generate the server-side logic that runs in the developer environment cloud. It generates the RESTful APIs, the structure that you saw, and then it generates the cross-browser client that you need available as well. And it can be fully debugged, it can be unit tested as well. It's how we built a lot of Codenvy there. And so we're actually here, we're hoping to get usage of the SDK. We want to develop the ecosystem around this. We want to start developing a lot more plugins. We built about 55 or so ourselves and our partners. But the syntax is pretty straightforward. This is an action class. So this is something that's going to do something. So when this action is triggered, it's just going to open up a window. It's going to put hello world into the window. This is the actual extension itself. It's pretty straightforward. It takes, you use injection to insert the parameters. You can have many parameters that get inserted into the extension. In this case, the register action item. So you're registering the action class to some ID that's there. And then you're going to add that action to a menu item. So the second one gets the main menu, and then the third one adds that action to the item at the bottom, the last. And so you can see here, now you've got a menu item. On the bottom is a hello world menu item. If you click that, this alert would show up. And just for shits and giggles, print to the console, hello world as well. So that's a kind of a multi, hello world plugin that you could write. You then compile that, you throw it into the SDK, and you'll get this windowing app, which could be used for Cloud Tool. We have, most of our business is going to be on-prem. So we build this system, this cloud system, so that it installs on-prem. You can run it, manage it yourselves. We'll also run a public cloud, and we will make that free for anybody to do anything in a limited amount of development, but cap your RAM at about a ½ gigabyte, somewhere in there. And then if you need more RAM, there's premium offerings for supersized systems on that. So with that, I'm going to wrap it up. You guys have been gracious. You even laughed at one of my jokes. That was nice of you. But we'll pause there, and I'd love to get any sort of opinions and feedback and answer any questions that you may have. Yes, way in the back. Just a little bit louder.
Sorry. You guys have shortcuts in the app. Are you able to customize them?
What kind of shortcuts are you looking for? Like keystroke shortcuts?
Accelerators for different actions in the IDE.
Yeah, so a couple of things on that front. So one, there's a lot of built-in key binding for almost everything that's in there. Like for example, if I have one still running here, there we go. There's a command palette here. And then, so those all have key bindings on it. That's one thing. The second thing is for our 4X release, we're going to work on a macro language as well, so that there can be process execution of multiple things on it. And then the third thing, I'm not able to show it here, but the editor is pluggable. So there are actually many different types of browser editors out there, and they do a bunch of different things. Orion is one. Orion has fantastic localization and internationalization support. CodeMirror is another. They have Emacs, VI, Sublime, multi-cursor key bindings on it. And so in our production system, you'll actually be able to open a file and you can select which editor you want to use. We're using the Google editor. This is the Collide Google editor. It's great for collaboration and certain components. So, so you can get those sorts of customizations as well. Yes, sir?
Profiling. You didn't talk a whole lot about profiling, and I was wondering if the Codenvy runners are going off for profilers so we can see where our code's spending time and how to improve efficiencies in our classes.
Yeah, I mean, the profilers will work just fine. So the way the recipes work, I didn't show it here, but you can override any of these recipes. So all the examples I showed today were embedded system provided recipes, but let's do just for fun. Do I have a good one? Yeah, the chef. See, what I love about these factories is if I need a new environment, I just click it and it loads. We actually think we can do some really fun stuff with these. This run DC5Y is a custom recipe here. And so in this current version, if you provide a run.dc5y or a build.dc5y or a debug, instead of us following our normal procedures for a build, a debug, or a run, we will instead use this recipe, create the image, and execute whatever commands you tell us to do. So in this image, you can have whatever profiler, you can open up whatever ports. These images are multi-process. So in a single recipe, you can have a database, you can have an app server, you can have an ESB all running at the same time across multiple ports, and the system will honor that there. So you can have the profiler, you can have the profiler port, and still view that in the system. All right, anything else? Yes, sir.
Does your profiling also include everything for the database, looking at procedures and indexes and all that fun stuff?
Profile, meaning we have a data source capability where you can connect to a database. We also have a SQL editor as well, and you can do, so if I came back in here, and let's go here, new SQL file, So it's mostly for developers, right? You can, connect to any data source. I think we support 8 databases out of the box. All SQL, nothing on no SQL stuff yet. But then you can execute queries here. You can take the SQL and bind it in to the code on that. I don't know if that answers your question on the profiling front.
Good enough.
This is what we can do today.
Okay.
All right. Okay. Yes. And then, he was faster.
So all your examples showed web-based UIs and console output, which works really nicely for web. But if I'm like using AWT and like GUI components on the local workstation, how's the Codenvy environment render that?
So yeah, like if you were doing a mobile app, like an Android app, you take the APK and after the post build, the assets are available for download. So you just download the asset direct to that device and then you could use it there. So what we showed here is when we slapped on a VNC client and whatnot, and you can gain access to that. We can eventually do something like if you're building an Android app or the equivalent, we could slap a QR code on here so that in the output you see the QR code, you just put up the Android device, you scan it, and it'll download it and activate it that way. So that sort of thing. We've tested this with Windows systems doing .NET. Because our builders and runners, behind the scenes, they're pluggable. So even though we're using Docker here, we've slapped on a .NET server, and the slave will still execute the .NET capabilities. You've got the C# code in here, and the results come out as well. So you can get creative that way with it. Yeah.
So might be some severe number crunching right overnight in the system. Will that be a problem?
Sorry. Can you say it louder?
So if I do lots of number crunching overnight
Yes.
in the system, will that cause a problem?
If I do a lot of number crunching overnight, so that's a great question. The way we're managing the system in our free accounts, in our commercial situation, 0.5 gig of RAM, but we cap the length of your runs and your builds. So I think the build timeout is 3 minutes, and the run timeout is 10 minutes. So if you then get onto a premium plan, and our entry level there is 2 gigabytes. We then give you 2 choices. Choice number 1 is we still get to terminate things very aggressively. And if you do that, because we get to save on our costs, we'll give you it's like 1/3 of the cost of the other option, which is always on. And if it's always on, then you get a 24/7 allocation, and there's no timeouts associated with that. So to answer your question, if you've got the right configuration and you start with the number crunching, no problem, go to town, have at it with it. We've got the cost down so far that we're going to be able to offer 2 gigabytes of RAM on a premium tier, and if you let us have the timeouts, it'll be $1 a month. $1 a month for 2 gigs of RAM on this. All right, I'm about out of my time. I'm going to hang out here tonight, guys, but thank you so much.